Today is our 4.1 through 4.4 review session. So really I'm just going to kind of go through some example problems. I don't have a PowerPoint and you don't have a note sheet. I'm just going to go through some example problems so you can kind of see some additional examples of how we've done some of these things from 4.1, 4.2, 4.3, and 4.4. So you're welcome to follow along with me. If you just need to fast forward and see some of these things, this is one of those videos where you don't have to go through all of this stuff. Just go through the stuff that's necessary in order for you to be able to complete the review tomorrow in class. So let's start with 4.1. 4.1, we're going to have this problem, which is where we're setting up matrix equations. So we have the matrix 2x, 3y, and negative z. And we're setting that equal to 2y minus z and 15. So when I set up these equations here, we're going to have 2x is equal to 2y. We'll have 3y is equal to negative z. And then we'll have negative z is equal to 15. So now it's our job to solve this. Well, these ones all involve two variables. This one is the only one that involves only one. So here we can say that z is just equal to 15. If z is 15, I can go back up here and say that 3y is equal to, it's a negative 15. 3y is equal to a negative 15, which means that 3y will be equal to 15 and y is equal to 5. And then if y is 5, I can go up here and we have 2x is equal to 2 times 5. So we'll have 2x is equal to 10, which means x is equal to 5 as well. So then we have 5, and negative 15 is our answer there. So remember, each individual piece is equal to the individual piece of the equivalent matrix. So not all of them have to deal with systems, because this is technically a system of equations. Not all of them have to deal with that. Some of them might be a little more straightforward. So we could have something like this, where we have column matrices. So we're going to be looking at 2x, negative y, and 3z. We're going to set that equal to just a column of numbers, 16, 18, and negative 21. So here, each of our variables can be found individually of the others. So we have 2x is equal to 16, so x is equal to 8. And we have negative y is equal to 18, so y is equal to a negative 18. And then we get to say 3z is equal to negative 21, so z is equal to a negative 7. And that's most of what we want to take away from section 1. Section 2 is where we start to incorporate some of our operations with matrices. So I'm just going to give you a few examples of those. So for this first one, we're going to be subtracting. So we're going to have 45, 36, and 18. With 63, 29, and 5. And we're going to subtract away 45, negative 2, and 36, 18, 9, and negative 10. Remember with subtraction you could do this two ways. You could just go through and say 45 minus 45, Again, it's easy to forget to use that negative and to change the sign, so I suggest actually rewriting all of this. So we'll keep this one the same with all of its numbers. Change this to addition, and it'll become negative 45, positive 2, negative 36, negative 18, negative 9, and 10. So now we have 45, and a negative 45 gives us 0. Well, 36 and 2 is 38. 18 and negative 36 is a negative 18. 63 and a negative 18 is 45. 29 and a negative 9 is 20. 5 and 10 is 15. And that is matrix subtraction. The other thing we did in this section was we did some addition, but we also did some scalar multiplication. And with this one we have things like this. We'd have 4 times the matrix, negative 8, 2, and 9. And then I'm going to be subtracting 3 times the matrix, 2, negative 7, and 6. So I'm going to go ahead and distribute this to every element inside here first. So we're going to have negative 32, 8, and 36. Again, I'm going to distribute the negative 3 and make this addition. So we're going to have negative 6, positive 21, and a negative 18. And now we add them. So negative 32 and a negative 6 is a negative 38. 8 and 21 is 29. 36 and a negative 18 is a positive 18. And so our final answer is negative 38, 29, and 18. And that's most of the takeaway that you want to have from section 2. Section 3, we started looking at matrix multiplication. So let's go ahead and look at multiplying a few different matrices. We'll start with a 2 by 2. So we'll start with 2, negative 4, 0, and 5. We're going to multiply that by another 2 by 2 of 1, 3, negative 2, negative 1. So remember, when we multiply matrices, you move across the first one and down the second one. So we have 2 times 1 is going to give us 2. Then move across and down. So negative 4 and negative 2 is a positive 8. And we're going to add those together to get the first element. Then we have 2 times 3 gives us 6. Negative 4 and negative 1 is a positive 4. Then move down to the next row. We have 0 times 1 is 0. 5 times negative 2 is negative 10. Then we have 0 times 3 is 0. 5 and negative 1 is minus 5. Simplify that, and we get 10, 10, negative 10, and a negative 5. But the matrices do not have to be the same dimensions. We might have things like this. We have this 2 by 3, which is negative 1, 0, 2, negative 6, 5, and negative 3. I'm going to multiply that by this 3 by 1, which will be negative 2, 1, 7. So let's go ahead and multiply these. Again, multiplying across the first and down the column. So we're going to have the first one be negative 1 times negative 2 is 2, 0, and we get 14, so 2 and 14 is 16. And then we have negative 6 and negative 2 is 12, plus 5 is 17, minus 21 is a negative 4. And so our final answer is a 2 by 1, which is 16 and negative 4. Remember that when you're doing matrix multiplication, the two middle numbers of the dimensions have to match, and the result is the outer two numbers. And let's go ahead and cover section 4 very quickly with transformations of matrices. So these transformations of matrices cover translations, dilations, rotations, and reflections. Recall that rotations and reflections uses matrix multiplication, of which there's those 3 specifics for each of them, and you will not have to memorize those matrices for each of those. You will only have to memorize what operation to do with each of them between translations, dilations, rotations, and reflections. So let's go ahead and I'm just going to give you one example of one of them, because remember, dilations take scalar multiplication, translations, you're using matrix addition and subtraction, rotations and reflections are both matrix multiplication. So I'm just going to give you a quick example of a reflection. So we're going to go ahead and look at the coordinates M, N, and O. M is located at 2, 4. N is located at 3, negative 5. And O is located at 1, negative 1. And we want to reflect this over the y equals x line. So again, we're going to multiply this by that matrix 0, 1, 1, 0. And so by doing this, we have to first create our vertex matrix. That's going to be 2, 4, 3, negative 5, and 1, negative 1. And now we multiply across and down. So we should end up with the exact same size matrix that we started with over here. We have 0 and 4 is 4. 0, negative 5 is negative 5. And then 0 and negative 1 is negative 1. And we have 2 and 0 is 2. 3 and 0 is 3. 1 and 0 is 1. So then we have the new coordinates. M prime is 4, 2. N prime is negative 5, 3. And O prime is negative 1, 1. And that is most of what we covered in section 4.